Won't you please, won't you be my neighbor? That should be the theme song for IPv6, because when IPv6 needs to do discovery, for example, is there a local router on this network? Or, wait, what's your layer 2 address? I want to forward you a frame and that kind of stuff. It's going to use a protocol called the Neighbor Discovery Protocol. So in this video, you and I get to take a look at a few examples of that, and we'll lab it up and actually put a protocol analyzer on it so we can see the Neighbor Discovery Protocol in action. So in the previous video, we just configured this interface right here at gig 0/1 on router 3 with an IPv6 address. We put it in longhand. It showed us what the shorthand could be, which was great. And that prepares us on this router. If we bring up a computer on that network, this computer, using Neighbor Discovery Protocol, it can actually ask for, it can say, hey, is there a router out there? And that's called a router solicitation. And that router solicitation is sent to a multicast group that all routers are plugged into or listening to, which is FF02::2. So if the client sends a router solicitation in saying, hey, are there any routers present? This router R3, because it's enabled for IPv6 and for routing, it can respond back with a router advertisement saying, hey, welcome aboard. Got your message. And by the way, this is network 2003 DB8:2:11/64. 1, 2, 3, 4. I want to make sure I have 4 groups there. So when it advertises this network, that last colon represents everything is zeroed out to the right of it. It's also representing here with the 64-bit mask that this indeed, up to this point, is the network. Now the benefit of that magic is that a client can come up on the network and automatically discover what the network is without DHCP or any other kind of IP services, just using the native Neighbor Discovery Protocol in the world of IPv6. So router solicitations and router advertisements are an example of Neighbor Discovery Protocol functions. And behind the scenes, they're also using ICMP as a protocol to help facilitate all of that. And while we're talking about NDP, another feature that exists in the Neighbor Discovery Protocol is called a neighbor solicitation. And neighbor solicitations come in handy for a variety of reasons. One of them would be, let's imagine we have a computer that's up and running, and it needs to know the layer 2 address on an interface of another device on that same network. So perhaps R3 is our default gateway, and this PC wants to learn about that layer 2 address of its default gateway. So in IPv4, we would use an ARP request, which was a broadcast that went to all the devices on the network. Well, in IPv6, we don't use ARP, and we don't use broadcasts. So instead, to learn a layer 2 address on a local network segment, we use a neighbor solicitation. And then based on that neighbor solicitation being sent, there can be a neighbor advertisement, which is advertising the layer 2 address. So a similar result as far as learning the layer 2 address of another device on your local network, but instead of using IPv4's ARP, we're using neighbor solicitations and neighbor advertisements. So just for fun, let's do this. Let me clean the screen up a little bit. And let's confirm that R3 is still, we just did it a moment ago, but I just want to confirm that R3 is enabled for IPv6. And once we verify that, let's bring up this PC, which will automatically do a router solicitation if it's enabled for IPv6. There should be a router advertisement from R3. And as a result, the PC should then learn about this 2003 DB8:2:11 network, even though we have not configured it locally here on this PC. So let me bring back the console for R3 here. And the command line interface, or AKA the CLI, is a very common way to work with networking devices, although there are a lot of graphical user interfaces as well. It just kind of depends on the device you're using and what's most convenient at the time you need to use it. So here in R3, if I hit the up arrow key again, it says on gigabit 0/1 that it has this IPv6 address, the globally routable address, and it's got this link local address. Fantastic. And it's also joined the multicast groups for routers. So that way, if this PC does do a router solicitation, we should be able to go ahead and see it. In fact, let's do this. Let's capture the traffic and we can look at it. So right here on this router, I'm going to right click and go down to capture and say I want to capture traffic on gig 0/1. We'll click OK and give that a chance to start. And I just want to verify I'm seeing some traffic. Great, I'm seeing some traffic on that interface. And let's go ahead and power up this PC. So I'm going to right click on this PC. I'm using EVE-NG for this virtualized environment, by the way. So I'll right click on this computer. We'll click on start and away it goes. All right, and I'm seeing in the packet captures, I'm seeing them show up, which is fantastic. All right, let's bring up the interface for this PC as well by clicking on it. And then I'll open up a little remote desktop session to that computer. So that is right here. And I'm just going to bring up a command line on this little Linux computer. So we'll go to System Tools and go to a terminal. And let's do ifconfig to take a look at the IP addressing information for Ethernet 0. And look at this. It's got an IP address for IPv4 of 10.3.0.50. And it has an IPv6 globally routable address. Look at that. Of 2003 DB8 211. And it learned that information from the actual router. It sent out a router solicitation, got a router advertisement, and that's how it learned about the network. It also has a link local address, FE80 right here. And so if we did a ping, and let's do a ping to 2003. In fact, I'm going to cheat just a little bit. I'm going to go back to the console, and it's going to I'm going to copy this address, 2003 DB8 211B, and that way I'll save a little bit of time typing. And let me get that out of the way. And I'll just paste it right there, and that way I don't have a typo. And I'll do a -C for how many times. I'll say, let's ping them 5 times. So I'm doing 5 pings, and I'm seeing the capture here that's showing up as well. All right, fantastic. So let's go ahead and click on stop, and we'll come back to this capture in just a moment. So we have router solicitations, router advertisements, neighbor solicitations, neighbor advertisements, and behind the scenes, the reason I just did that ping from the PC over to the router was because the PC would need to learn the layer 2 address of that interface, and so it would have done a neighbor solicitation to the router asking about what is your layer 2 address. So that all should be in the capture. In fact, I see it right there, but we'll get to it in just a moment. And as far as IP addresses go, with both IPv4 and IPv6, computers need an IP address. They need to have one. There's also going to be a mask that identifies from that IP address, which part's the network, which part's the host address. They also are going to need some type of a default gateway, learned dynamically or statically configured, that tells them how to get off the local network. So if our PC here in Florida ever needs to send a packet to some other remote network, it needs to forward it over to a default gateway, R3, so that R3 can make a routing decision and forward it towards the destination. Also, more than ever, we're going to need domain name system. So PCs and devices running IPv6, they would need to know who the DNS server is, so they can go to www.cbtnuggets.com, and if it's an IPv6 address, dynamically get that IP address back, and then forward packets to that IPv6 address. Because I can tell you this, not too many people are going to be happy about ever having to put in manually an IPv6 address to reach a website. So these concepts regarding IP addressing and what clients need, that's consistent between IPv4 and IPv6. Now, in IPv6, we can use DHCP, just as we can with IPv4, where you have a DHCP server who hands out the information. And with IPv6, there's some additional options and tweaks regarding how that works. But the automatic assignment from a DHCP server, that's a consistent idea between IPv4 and IPv6. But IPv6 has something unique as far as getting an IP address, and it's called SLAAC, S-L-A-A-C. And the acronym stands for Stateless Address Auto Configuration. And effectively, it goes like this. This client, when it did its router solicitation and saw the router advertisement come back, it knew the network address at that point. The process of SLAAC, which is Stateless Address Automatic Configuration, that allows this PC to automatically configure its own IP address. Now, the network portion, it learned from the router solicitation, because the router knows exactly what the network address is, it shared it, and then the PC used a process called EUI64. And that's an acronym for Extended Unique Identifier, and there's 64 bits worth of that. Effectively, it means that this PC, leveraging EUI64, was able to go ahead and assign itself the last 64 bits, or the host ID portion of its IPv6 address. So when you think of SLAAC and EUI64, I'd like you to think of the word auto. It automatically determines and learns what the network it's connected to, and it automatically gives itself a host address on that network. And that's through some magic of taking its layer 2 MAC address, which is 48 bits long, adding 16 more bits to it. Also, it flips like the 7th bit over. The actual details aren't too critical, but rather the concept that it's happening is important to know, because this PC right here, we just powered it on and it automatically figured out what network it's on, and it also assigned itself an IP address for a host ID, and we verified it was working because we were actually able to ping from this PC over to R3 using IPv6. And this packet capture has all the details for what just happened as well. Let's take a look. Now, this protocol analyzer, this is Wireshark. It's a free protocol analyzer. It's been looking at all the traffic that's going in and out of the interface there on R3. And it's collected information regarding all the traffic it saw, including IPv4 and IPv6. So I'm going to put a filter in place up here in the top left. I'm just going to type in IPv6. And that way, this display filter, I still have like 165 packets that are in this capture, but down here at the bottom it says that only 24 of them are being displayed, and that's because only 24 of them are IPv6, which is what we want to look at right now. So this packet, which in this capture is packet 28, this is coming from the link local address on that PC, and it's going to FF02::2, which is the multicast address that all IPv6 routers are listening to. And this packet is a router solicitation. Effectively, it's the PC saying, hey, do you know what network we're on? And then in response to that, here in packet 29, we have the router advertisement, which is coming back from our router. And if we look at the payload here, and let me go ahead and bring this up just a little bit. Here in the payload, among other things, it has the information about the prefix or the network. The prefix is a fancy way for saying the actual network address. So here in this router advertisement, the router is advertising that this is network 2003 DB8211 with a 64-bit mask. At which point the client said, whoa, great. And it used that in combination with EUI64 to calculate its own host address on that network. And so what's happening here in packet 30 is it calculated the address it wanted to use using EUI64, and it's just doing a double check here. It's called duplicate address detection. It just wants to make sure that the address that it's about to use isn't currently in use. So it's sending a neighbor solicitation out in the hopes that there's not going to be a response. Because if somebody responds, that means somebody else is already using that address. So after a few moments when there's no response to that neighbor solicitation, the PC then decides, yep, it's safe, I can use this address. No one else is using this exact host address on this network. Then a little bit later, I did a ping to the router. And that's what triggered this neighbor solicitation. This is the PC doing a neighbor solicitation saying, hey, whoever has this IP address, 2003 DB8211:: beef, I really need your layer 2 information. And as a result, the actual router responded back with a neighbor advertisement, which includes, among other things, the layer 2 information. So here in the response in the neighbor advertisement, it includes the MAC address, the layer 2 address of the router, which is ending in 030001. So we can verify that the layer 2 address on the router by doing a show. And again, the commands are going to vary slightly based on the platform you're running on. But if I wanted to see the details for gigabit 0/1, I can do show interface gigabit 0/1, press enter, and then scroll back to the top a little bit. And there is the layer 2 address on this device. 500000030001, which matches up with that. Now here, they have 2 characters and a colon, 2 characters and a colon to represent the 48-bit MAC address, the layer 2 address. And in the output on this vendor's platform, they put 4 characters in a period and 4 characters in a period and 4 characters. But anyway you slice it, it comes out to 12 hexadecimal characters representing that layer 2 address. And then after the PC knew about the layer 2 address, it then proceeded to do the pings, which is using ICMP in the background for testing that connectivity. So there's the ping request and a response, and that goes on for 5 times. 5 requests, 5 responses. All right, let me go ahead and close that. So in this video, we've identified some characteristics regarding IPv6, including neighbor discovery protocol, and the fact that we can do automatic address configuration by doing router solicitations, getting router advertisements back, and then using EUI64 for the generation of that last 64 bits of the IPv6 address that this computer is going to use on that network. Now, one of the challenges that comes up is that what if in our enterprise we want to move to IPv6, but we're not completely there? We can't just flip a switch and do everything overnight. What can we do to transition or to work around maybe areas of our network which don't yet have IPv6 capabilities, but we still want to send traffic over them? So in the next video, I'd like to talk with you about transition techniques that are commonly used when a company or an organization is migrating to or moving towards IPv6. So we'll do that in the next video, and I'll see you there in just a moment. Hey, thanks for watching, and subscribe right here to get the latest information from CBT Nuggets. And if you're new to or considering a career in the world of IT, head on over to CBT Nuggets and sign up for a free trial.